All right, this is our first section of actually completing the hypothesis test. So like your notes for 8.1 have parts that you'll need for this 8.2, so keep those handy. So we have a little bit of notation up here. So just remembering that N represents, this kind of went weird. That's okay. N represents our number of our sample. P represents the proportion, right? And if it's just P, not P hat, then it is representing our full population's proportion. The P hat, which we should really write as, I don't know what that line is. There we go. So we should really write P hat like this. It is your sample proportion. I don't like that there. It just didn't come through really well. It comes through fine on yours. It just is the notability. It needs to be moved to notability from a PDF and not Google Docs. So, all right. So Q hat is 1 minus P hat. We already seen that in some of our formulas. So we have some requirements. So we're looking at a proportion today, and we're looking at like a claim that someone made. We're going to write our null hypothesis, our alternative hypothesis, and then we're actually going to decide to have evidence for or against that null hypothesis. So we're going to do that full idea. So we do have these requirements. I'll just tell you, I have to list them. We have to talk about them. Because if you're doing your own project, your own thing, then you have to meet these, right? Or if you're working on these in biology or some other course. It is the sample observations are simple random. They have to be random, not necessarily simple random, but they have to be a random sample. The conditions for binomial distribution, which we've only really talked normal distribution. Binomial distribution is there's two things, yes or no, like proportion, you either are for it or not. And these are the conditions. Each trial is success, failure. Basically, the conditions are if you take the number of samples you did, like maybe you collected 500 samples. If you times that by your p-value, it has to be greater than 5. Think about that. If you are a very low sample and you have something like you're testing a claim of 1%, so super small number. If I did like a sample 5 people, 1%, that's 0.5. It's nowhere near 5. It's basically, if you're going to test something that's a really small percentage, you have to have a large number of samples. So this kind of keeps that in check with people who want to run things like, oh yes, take this medication, it'll cure all cancers, right? Or drink this water and it'll cure your cancer. Well, what was their sample size, right? How many people's cancer was cured, that kind of thing. This will keep people in check for those type of things that are like more serious. Okay. All right. And this just kind of separated on mine. Yours should look normal. This should be like a P hat right here. Oops. P hat. My hat's up here. And then it like did a space. I don't know what it's doing. So what are these P values? So what's so cool is when I was back in my day, so if you're old, we would have to look up tables of values and we would have to find what we called our critical value. That's our Z-score, right? Where you're doing the percent in the normal calculator. And it's that value you get that's usually around 2 that we've seen quite a bit of times. But we would have to get that value and then get what we call the test statistic and see if it's below or above it to see if we reject the null or we accept the null. Now we have something called the p-value. And it is really where the calculator calculates the probability of being in the rejection region. And it makes it way easier. And that should say rejection region. So if you think about like a traditional two-tailed, right? It's the probability of being in this rejection region. Okay, rejection region. And if we're there, then if we reject the null, if we're in that section. Okay, so we'll go with the alternative hypothesis. whatever it might be. So to find this, we just use StatCrunch, okay? And it's a separate section for all of these. So we have a proportion, and we're gonna focus on means, which use T's and Z's. And that's all we're gonna do. We won't get to chi-squared, which is just using a standard deviation, which is a great estimation thing too, but it's not, it's the same idea. You could apply to that if you need to for biology, which you will. Okay. And then we'll make our decision. So this p-value method is what I'm pushing for you to use. So if that p-value is low, so it's below your critical, significant value, I had to think of the name of that one. So let's say you want to be accurate at 95%, right? Want to be 95% confident or accurate. Then 0.05 is your significant value, and you need the p-value to be lower than that to reject the null. So if the p is low, you reject the null. Okay? The null must go. If the p is low, the null must go. If it's bigger than that value, then you fail to reject the null. So you're saying we have evidence in favor of the null. So we either have evidence against the null or in favor of the null. That's how we word it. Reject it, accept it. That's it. Okay, this is just some wordy stuff for you, just to kind of help with that accept or fail to reject. We don't like the word accept, so we use fail to reject. You know, those, so we either reject or we fail to reject. Okay, so we have this test statistic, and this test statistic is used for the other method, really. It's critical value method. We don't really use this method anymore, but you still have to find this test statistic in all of your homework. So we'll find it on StatCrunch, or you could use this formula, okay? And this talks about p-values, critical values. Let's go through this example here. Okay, we have 1,009 customers were asked if they're comfortable having drones deliver their purchases. 54% of them responded, no, I'm not comfortable. Use these results to test the claim that most consumers are uncomfortable with drone deliveries. Okay, so if we were to do the check, which we don't always do, we just kind of assume when it tells us, when it tells you it's already got this piece in there, it'll have that in your wording a little bit. But if I was going to, we would say, okay, was it a random sample? Sure, it said it was random. So we'll say, sure, it was random. 2 says, there's a fixed number of trials with either yes or no. Yes, you either went with the drone or you were against the drone. We had 2 things. We're good. Last one, however many people's times the 0.5. And where did the 0.5 comes from? It comes from the claim, because we're saying most people. So most people goes with 0.5. So we times those, and that's way bigger than 5. We're fine. When we're testing claims with a 0.5, we're usually pretty good. If you're testing a claim like 0.01, that's when like a super low percent, that's when that sample size might have to be a lot bigger. So our checks, they all made, we're good. We can actually move forward. So for the p-value method, we would set up our null and alternative first. And we know if we say at most, or most of them, or well, at most is greater, but like because this problem is greater. But if they say most people, anything like that, you're just going to use the 0.5. Or if you're not given the proportion to use, you use a 0.5. That's just the middle, right? So we're going to say our null is equal to that 0.5. Remember, we label it HO ... P for proportion equals that halfway mark. Okay, then over here, ignore the original claim for just a second. You're writing like, what are they claiming? Are they claiming, or not claiming, but what are they trying to prove? A greater, less than, or did they leave it blank and you go either direction and it's a two-tailed test, which is not equal? Well, this one said greater. Okay, so we are going to put in a greater signal there. And I always label which one was my original claim. So if I go back up and read it, it says, blah, 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 blah. Use these results to test the claim that most consumers, that's more than 0.5, are comfortable with the drone. So at that most consumers are comfortable. So that is going to lead me to a greater than 0.5, that most people are comfortable. Okay, and that is the claim. The claim could have been it equals half the people. So the claim could be the null or the alternative. Don't get that mixed up. It's always equal on the null. Always, always, always. The other one has to do with the problem. Greater than, less than. Those are one-tailed or the two-tailed with the not equal. Okay, and then we had just 0.54. And so in order to get that 545 number, you could think of like 0.54 times what would give you this. So you divide to get the 109. I showed that just in case. And then this is our proportion. Let me write that so much prettier. 545 out of 1,009. There we go. This is ugly. Okay, so in your note packet, I already did it in StatCrunch just to kind of show you. So you're going to go to stat proportion because we have a proportion. You're going to put the 545 out of however many, and then now you're going to do a hypothesis test. We are testing half, like most people, right? And we're doing greater. So null doesn't even let you mess it up in StatCrunch, which is another benefit. It is equal. It won't even let you change it. So therefore, it's trying to lead you towards the right answer. And then this will give us this little chart here, all this information. Double check your counts. You can double check your hypothesis here. Sample proportion, that's 54% based on the sample. So that is greater, but is it greater enough to really say, yes, this is greater, right? So a lot of times we're testing something, we know we have evidence showing, oh yeah, most people are comfortable with drones delivering your stuff, right? But you have to decide whether it's really enough of a difference to truly be enough of a significant difference, to really be able to say that is what we have evidence in favor of. Lost my train of thought a little bit. Okay, Z, this is that Z statistic that you have the formula for. That is for the critical value method that I don't really want you to use, but I want you to be aware that it is there. What I really care about is a p-value. I have 0.0054. We want to be accurate at a 95, so 0.05 level. So if you think about it, is 0.0054 less than the 0.05? Yes, it is. So if it's less than my significant value, it is, then the null must go, right? So the null, we're going to reject the null. And that's what I put all down here for you. We're rejecting the null, so therefore we support evidence in favor that that the more than 50% of the people, right? We're greater than 50% of the people are okay with the drones. All right. So if we did the critical value method for this exact same problem, and you can see I put, it's more work. I prefer you use the p-value method, but I'm going to show it to you. I don't even care what the problem says in StatCrunch or in your homework. You can always use the p-value method, okay? So use the critical value method. So what we're looking at is we got this test statistic of 2.55, and that literally came from right here. Or it can come from this ugly formula right here, okay? There's that ugly formula. You find your p hat minus your p. It's going to be your value of the whatever the p is on your population is your p. P hat is your sample. Okay, so you can do that formula and you will come up with this 2.55. Then what I do is I get on the normal calculator for the 95% accurate, we have to go in here and do I have less than here instead of greater. Mm, yeah, my graph is I just realized that. Okay, let me show that split screen real quick. So if I'm in StatCrunch, just ignore that data I have right there. But if I'm in StatCrunch, I'm going to go to Stats, Calculator, Normal, and I want this to be, did I say 95? I think I sure did, 0.95, and I want this to be greater and compute, and that's going to give me the negative 1.64. That's why it is the same number. That's still tricky because I was like, it's greater. Okay, so it gives us so it's given the same value, whether you're greater than that value or less than that value. So that's probably how I didn't notice my graph was kind of going the wrong direction. But is this 2.55 greater than this number here? So yes, it is. So we have this bell shape, we have this 1.6 value, 4, 5, and we're going to ignore this, sorry. And is this number above in this rejection region? Yes. 2.55 is in that rejection region. Um, it's still the same number just because of the probabilities, but basically the critical value method, you just look at whether or not that test statistic is above that, or if it's in a two-tailed, if it's above or below in either rejection region. So if it's greater, it'd be in that greater one. If it's less, then it's going to be in that less than one. So that method to me is a little more tricky. And this is what I learned. And then I would have to look through charts to try to find the 1.645. I didn't have technology. So to me, it's like super exciting that you can use this p-value method. And it has only been in the last, I think, 15-ish years that they've been using it. So it's a newer math idea. So we're going to just say, put our data in the right section in StatCrunch, and we're going to be like, okay, is the p low? Then the null must go. That's what we're going to focus on. So let's do a problem from the very beginning, and we'll use StatCrunch, and we're only using the p-value method. Okay, so in a study of the accuracy of fast food drive-through orders, one restaurant had 29 orders that were not accurate among 298 orders observed. Use the 0.05 significant level. Now they could have said 95%, you come up with the 0.05, so be careful there. To test the claim that the rate of inaccurate orders is equal to 10%. Blah, blah, blah. Okay, what is our hypothesis? This is right? Null alternative. So do we have a P or a U for mean? We have a P value, right? Because it's a proportion, percent, whatever. And then for our null, we know this has to be equal. So what number are we actually testing? So it says use a significant level to test the claim that the rate of inaccurate orders is equal to 0.10. So we're using 10%. That's the claim. Okay. And it's just the rate or equal to. So I don't see anything about like greater or less than, it just says equal to. So what do I use if it's not saying greater or less than? Not equal, because it's going to then be two-tailed. Basically, it could be lower or higher. We're going to see how well this restaurant's doing. And it's always that same claim value. Okay. And then the actual claim is this one. I like to label my claim. It helps me with my conclusion, and it can be on either one. Okay, now let's go ahead and head over to StatCrunch. Okay, I'm going to close this out. Well, that's okay. I mean, it has some things on here, but that's okay. Where do we go if we have a proportion? We're going to go to stat, close all this stuff up, and we need to go to the proportion section. You see that? Proportion stats. Now, a proportion does use a Z. It is normal, but in order for StatCrunch to do it, it has to be separate. It's just a StatCrunch thing. So proportion stats, well, most calculators. And then one sample, because we only have one sample. We haven't got to two samples. And we don't have our data. We're not listing out, what was this one out? Accurate order, not accurate, not or accurate, not accurate. We don't have that. So we always have summary, almost always. And we were given straightforward that 29 people, what was this one? They were not accurate. So 29 were not accurate and 298. So those were our two numbers. And then for our null, we need to change this to 0.1 and then not equal. So we're good there. So it doesn't let us put our null in wrong, which is my favorite. Compute. Oh, so that is a super high. What is 29? Yeah, so 0.09. Okay, so let's look at what we have here. You see proportion P, 29 out of 298. There's our proportion, sample proportion is 0.9, almost exactly at 10%. So we always ignore the standard error because it actually has nothing to do with our margin of error with our confidence interval. It's a different number, we just ignore it. So our z-stat is a negative 0.15 and our p-value is 0.87. Really, that z-stat really just tells me I'm below on this one. And we might have to write that into MyMathLab, but honestly, we're not going to use the method that uses that z-stat. Okay, so our p-value, we're going to write that over here, is equal to 0.8772. That is super high. So is that bigger than 0.05? Yeah, by a lot. So if it's low, the null must go. We aren't going to reject the null. The null's not going away. So we fail to reject the null. That's the wording we want to say. So we fail to reject the null. So I'm going to highlight it. Basically, this is what we have evidence in favor of. Okay. Oops, I highlighted the wrong one. Oh my gosh. That's just how my day is going. You already probably messed up your notes. Sorry about that. Okay, so we fail to reject the null. What does fail to reject the null mean? We keep it, right? So our number was so close to 10% that we really do have evidence that the inaccurate orders equal 10%. Okay. And so we fail to reject the null. We would state we have evidence in favor of the claim that 10% of the orders are inaccurate. That's what you're writing out right now. Okay. All right. This was me showing the, I just have a little solution there so you know what it should look like. In a study of 800 randomly selected medical malpractice lawsuits, it was found that 476 of them were dropped or dismissed. Use 0.01 significant level, so a little bit higher, that's 99%, to test a claim that most medical malpractice lawsuits are dropped or dismissed. I think they actually are. We just get sad sometimes and want to sue and blame people, and that's just the way it is. And sometimes they're just people being our doctors and they make mistakes. So let's think about our proportion. I have 476 out of 800. Okay, just thinking that through. And 476, oh, whoops, 476 divided by 800 is about, just because I wanted to look at it, is about 0.595. And then it says to test the claim that most medical malpractice. How do we test the claim? So we want our null and we want our alternative. How do we test the claim of at most or most people? We use 0.5, right? And we know it's a proportion and we know it's equal. So equal to about half. And this is going to just claim that most people. So how do I represent most people? You're greater than the 0.5. Okay, that's how we're going to represent. And which one is our claim? Do we claim that it equals half or do we claim it's greater than half? We claim this one. We're claiming greater. So it's an ugly M. All right, so let's go to StatCrunch. And in StatCrunch, we're going to go to stat and proportion. It's open right there with summary. And then we're going to say, all right, we had 476 out of 800. And our claim was greater, and it was the 0.5. And we compute, and here's our information that we have. We might have to put that z-stat in, but we really care about the probability, right? So our p-value is 0.0001. That is so small. So is that p-value smaller than our super small level of 0.01? Yes. So this is smaller than the 0.01. So yay. So if it's smaller, then null must go. Null must go. Goodbye, null. That means I reject the null and I have evidence in favor of our alternative hypothesis. I have evidence in favor of the claim that most people drop their claim against the medical profession. Okay. So I could write that all out. Rejecting the null means, oh, let's highlight it again, that we say yay to this one. We have evidence, we don't accept it. We just say we have evidence in favor. I think that's my last one. I'm going to skip forward. Okay, 5 is just kind of the wording straight from your homework. I just put it on here so I could talk about it a little. So if you look at this as like a 9-year-old science fair experiment in which she tested professional touch therapists to see if they could sense her energy field. Okay. She flipped a coin and selected her right hand or left hand, and then she asked the therapist to identify the selected hand by placing their hand just under her hand without seeing or without touching it. Okay, so here we go. And then so many or whatever. So they will make you pick your null. So when you look at these, you better be like, heck no, can't be not equal. It has to be equal. So there's only 3 more options. Is it less than, greater than, or not equal? You decide. What are you talking about? Is it two-tailed, one-tailed? And then you're going to put in the test statistic. That's straight from StatCrunch. You will put in the p-value, and then you're either going to reject or fail to reject. That's what the wording looks like. And so you'll have 2, and then you'll have to pick the one that actually matches the claim. So this one is, there is evidence warning a rejection of the claim that touch therapists use a method equivalent to random guesses. So whatever they talked about, we have that wording back in for our, if we reject the claim, whatever the claim is. So that's kind of how the wording and kind of how your problems will be set up. So we use StatCrunch after we find our hypothesis. We can get the test statistic, the p-value, and if the p is low, the null must go, which is this case. So you have evidence in favor of the alternative hypothesis. Okay, so we reject the null and keep going. All right. All right, I guess that's all I got for this. So where are you going in StatCrunch? To the proportion. section. Okay, good luck.